Hey guys, today we're going to discuss about why integration gives area bounded by the graph and the axes, right? So here we already have a graph. It's quite y equals to fx. Okay. Okay. So basically, we're going to find the area of from x to x plus h. Okay. But first, what I'm going to do is I'm going to pretend that there's an area here. Okay. All the way until x. All right. And okay, let me say that there's another area here. Okay, maybe I'll use blue color. Okay, so this is all the way, okay, up to x plus h, right? Okay, so what I'm going to do is I'm going to let the area, the blue area basically, right? And let's call it x plus h, right? So a is an area function, okay? So basically a of x plus h is basically the area, all the way until h. Okay, so anyway, I think I'm going to put the limit here, right, on the left hand side, okay, because otherwise we're going to have like infinite area, right? And infinite plus this area minus another infinite area, that's a bit abstract, so just for the sake of calculation, okay, although it doesn't really make a difference actually, but I'll just put the limit here, right? So this is a arbitrary limit. Let's call it k. Okay, so let's call it k first. Okay, so well, so our a of x plus h represents the blue area, all right, and our a of x, all right, represents the red area. Okay, so well, ultimately we are trying to find okay, so let's use green color here. Okay. Okay, so ultimately I'm trying to find the green area, right? Okay, so what do we do here? Okay, can I say that, okay, just use a pink color maybe. Okay, so just focus on the green area. Okay, I'm going to draw a rectangle here. Okay, so this is a rectangle, right? Okay, there. Now, what is the area of this pink rectangle, right? I just drew. Okay. Area of pink rectangle, okay, is given by, so how do we find area of rectangle, right? Length times breadth, right? Okay, so can I say that, or rather the height of this rectangle, or you want to call it the length or the breadth, it doesn't matter, right? This is actually fx, right? Because x, then this is fx. Okay, so can I say that this equals to h times fx? Okay, h is this times this. Okay, so let me just draw the rectangle again. Okay, this is the one that we're talking about. Okay, and this is fx, and this is h. Right, so the area of this rectangle is fx times h. Right, so h fx here. Okay, can I say that the area, right, the green area is basically larger than this pink rectangle? Okay, so you can see that there's this extra area here, right, that's greater than this pink rectangle. So I'm going to establish some inequalities here. Okay, I'm going to say that, oh, by the way, to find the green area, okay, it is basically a of x plus h minus a of x, isn't it? Right? because you take the area up to x plus h minus the area up to x, and you basically get this green area. Okay, and this green area is going to be larger than this pink rectangle. Okay, so I can say that it is larger than h, okay, times fx. Okay, let me draw another rectangle. Let's say that, okay, running out of colors. Maybe orange, right? Okay, so let's say I'm going to draw this rectangle now. Okay. Hopefully you guys can see this. Okay, orange rectangle. Okay, so can I say that the area of this orange, okay, rectangle is given by h times f of x plus h, right? Because at this point, so-called the y coordinate, okay, the y coordinate is f of x plus h, okay? So yeah, I'll just write it down like this. This is x plus h, and this is f of x plus h, right? Okay, so can I say that, you know, this green area is smaller than this area of this orange rectangle? Okay, so we have another inequality here. So this is h f x plus h, right? Because this is the area of the orange rectangle, right? The area. Okay, so now this inequality is quite important in the result that we're going to prove. Okay, can I take a limit, right? Can I say that the limit where h approach 0, oh, so basically I have to divide by h first. Okay, so let's divide by h first. And you have this. Okay, so this is f of x plus h. Okay, so yeah, that'll be easier actually. Okay, so let us take the limit now. Okay. Then we don't have the problem of dealing with 0 times fx and all those stuff. Okay, and this is limit h approach 0, a of x plus h minus a x over h, limit h approach 0, f of x plus h. Okay, so yeah, this is going to be an interesting inequality. Okay, so our fx here is quite independent of h, right? So taking the limit h approach 0, we still get fx. Nothing much has changed. Okay, if you realize from the first principles of differentiation, this term is actually dA dx, right? Okay, this term is actually dA dx. And well, for this part, okay, if h approach 0, f of x plus h will approach fx, right? Okay, now if dA dx is larger than fx but smaller than fx at the same time, then dA dx, well, it's kind of equals to fx, right? By the squeeze rule, if you have learned squeeze rule before. Okay, so dA dx is fx. Okay, that is important because now if I integrate both sides with respect to x, okay, integrate with respect to x, I actually get a equals to integrate fx. Okay, so area is actually integrate of fx. Okay, so our area is a function in terms of x, right? So I might as well write it as ax equals to integrate fx dx. Okay, so we kind of established our proof. Okay, now let me erase this and let's talk about actual question. So something more general. Okay. Okay, so let's say, okay, I have another graph here. Okay, and our graph looks, oops, okay, our graph looks something like that. Okay, and I want to find the area from A to B, right? Okay, so this is our fx. Okay. Okay, so I want to find the area from A to B. Okay, so imagine that there's a K here, like just now, right? It doesn't really matter actually. Okay, so if I want to find this area, okay, basically is A of B minus A of A, right? Can I say that? Okay, and well, since earlier we already established the result, ax equals to integrate fx dx. Okay, so I have to get this, right? This is basically integrate of fx. Let's use a big F to denote integral. Okay, so this is fx. But now this is b, right? So this is fb, right? Okay, so and this would be fa, right? Okay, so our area from A to B, right, is basically FB minus, okay, the area that we want is basically FB minus FA, which is integrate of B to A fx dx, right? So yeah, that's basically how integration is related to the area. Okay.